All right, so in order to know what the heck you're doing whenever you're trying to do math with significant figures, you obviously have to be able to identify significant figures in the first place. And there's usually a list of rules that are given, usually somewhere around 5 or 6. I'm going to give 6 today. And there is no shortage of people who absolutely hated learning this stuff when they did, including me for that matter. What I've done is to rearrange this and put pretty much all the easy stuff up front. And there's really only 2 that I wouldn't even call them hard. They're really more surprising. It may be a little bit tricky if you're trying to identify or not. And there's ways to kind of look out for those. So anyway, here we go on it. Rules for identifying significant figures. Okay, the first one I'm putting up is going to be the most obvious, which is that all non-zero numbers are significant. If it's not a zero, it's significant. If somebody weighs 185.4 pounds, that's 4 significant figures. All right, zeros between 2 non-zero digits, called trap zeros or sometimes called embedded zeros, are significant. If something weighs 101 grams, that zero is, that means something. That's not there just as a placeholder. That is the actual digit. There's kind of an empty value there. So 101 grams has 3 significant figures because it has that trap zero in it. Most of the time, you can just look at a number, and if everything in there is non-zero numbers, you're good to go. Everything is significant, but the zeros are really the only ones that you have to worry about. Any questions? All right, what are called trailing zeros in a whole number with a decimal are significant, like 23.0 seconds, which has 3 significant figures instead of 2. You might be tempted to think, well, that zero doesn't mean as much. It does. It's 23.0 seconds. If you don't believe me, if you know anybody that's really big in the track that runs track, ask them whether or not that last digit means anything or not. It absolutely does. All right, continuing on. Trailing zeros, the ones on the end, trailing zeros to the right of the decimal are significant. And notice it says to the right of the decimal. We're going to get back to that in a second. So 15.410 liters, that zero is significant. It's not, you can't just ignore it. It's significant. All right, the last 2 are the ones that sometimes will surprise people. People will have a little bit of trouble with, but I'm going to expound on those a little bit. So what are called leading zeros out in front? They're placeholders, and they're not significant. For example, 0.1 millimeters or 0.001 millimeters. Both of those, they only have 1 significant figure, and that's surprising to people sometimes. But it turns out all those zeros are doing are just acting as a placeholder. That lets you know that, like for example, in that second value, that lets you know that that 1 is in the thousandths place. Those 2 zeros in front of it, right up to the decimal, they're just there to let you know it's in the thousandths place, and that's it. So if you see zeros like that, those are not significant. That's one of only 2 that typically people have any trouble. And the second one is this, and that's probably because of similarity to some stuff we run into in the everyday world. Trailing zeros in a number without a decimal are not significant. For example, 70 degrees Fahrenheit. That's 1 significant figure. You would think it would be 2, but it's only 1, and the reason why is there's no decimal there. All right, the decimal is what makes it a zero significant. The other one, 93 million miles. That's the distance between here and the sun. Again, you think such a big number, all those zeros, the zeros would be significant. No, only the 9 and the 3 are significant. It only has 2 significant figures. All right. So just to run through a few examples and sort of put these little rules to use, we're just going to run through these real quick. And I'm going to do some really easy ones at first, like this very first one, 35.2 feet. Every single one of those is a non-zero digit, so it's obviously going to have 3 significant figures. 2.0 liters. Here's one where, somebody might be tempted to think it's only got 1 significant figure. No, both of those are significant, mainly because that decimal point is there. All right. 41 seconds, another easy one. They're both non-zero digits, and so you're going to have 2 significant figures. But if you have 41.0 seconds, that's another one where if you didn't know ahead of time, you'd think maybe there were only 2. No, there's 3. That 0 is significant because of the decimal being there. 0.07 miles. So something like this is probably the most common sort of mistake that a person might make. They might be tempted to think there'd be maybe 2 or 3 in there. after doing some of the other ones? No, there's only one. Both of those zeros are placeholders. 401.2 pounds. Now we know everything in there, with 100% certainty, everything in there, with a possible exception of the zero, is a significant figure. The zero is the only one we really have to look at. But since that's a trap zero, that's an embedded zero, it's significant. So we have 4 significant figures. 19.670 grams. Again, we know that the first 4 digits are automatically going to be significant. The last one, there's only one to question about, but since the 0 is behind a decimal point, it's significant. So it has 5 significant figures. 120 pounds. This is one that's a really common source of people getting goofed up on this. It's an everyday thing. It looks like maybe somebody's, body weight or something. And it looks like it should be 3 significant figures. It really does. But if you remember our rules, there's no decimal point there. So there's only 2. And then there's just the last little blur. People sometimes have trouble with this. But like, for example, in a problem, if you get a number like 121.4, and you're supposed to round it to 2 significant figures, for reasons which we're going to go over in just a little bit, the answer would be 120. If you 121.4, round it to 2 significant figures, it's going to be 120. The only 2 that you'd have is significant would be the 1 and the 2. So you just use that 0 after you round it as a placeholder. I just wanted to cover that since that's kind of a common mistake. All right, now, a refreshing thing is that scientific notation has really, really easy rules with significant figures. Basically, if it's in the coefficient, the number's out front. If it's in the coefficient, that is the number out front, it's going to be significant. So we have 6.022 times 10 to the 23rd has 4 significant figures. All right, because the coefficient has 4 digits. That's it. Couldn't be easier. 9.15 times 10 to the 16th has 3, because again the coefficient has 3 significant figures. Okay, there are 2 other types of significant figures, but we're gonna hold off on those, and those are going to be on the next video because I don't get the video too terribly long. So this is going to be the end, and we'll see you on the next video.